Hi, in this series, we'll be starting to do the H2 Mathematics 2022 Paper 2 for Singapore. So, first question begins with showing and understanding how to calculate an integral using substitution. And so what you do is you write your integral on your left and then you just have a line and then you write your substitution on the right. So if u equals to square root x plus 2, it must imply that x equals to u squared minus 2. And then the dx du, you just differentiate this, it will be 2u. So we'll see why we need this later on. And the next step in this is substituting the x as u squared minus 2 and the bottom as u. But here is a dx, so we need to convert it to a du to integrate with respect to u. And so to convert, the idea is dx du is 2u, so dx is kind of like an easy way to remember is 2u du in differential form. So this is like 2u du, and when you do it, you cancel the u, take out the 2, then you integrate u squared minus 2, which is easier. Then it becomes u cubed minus 3 over 3 minus 2u plus c. And then now, a key step that many students forget is that you need to resubstitute back the formula for u. So because you, in the end, you started with an x, you need to end with an x. For question 2, it kind of tests your understanding of mathematical modeling and differential equation, which we'll see in the later parts. So for the first part, it's really understanding mathematical modeling. So they tell you have a base area of 0.9, and what I like to do is to draw out the diagram, a rough one. So you just draw a random cylindrical container, and then the water is poured at a rate of k liters per second, and it will fill in 72 seconds. So first you must find the volume. So the volume is 0.9 times the h, but this is in meters cubed. See, this is in m squared m, and in the question they will tell you that 1 meter cube equals to 1,000 liters, and so you must convert it down to liters because the rate is k liters per second. And so now the time is just the volume over the rate, so it's 900 k h over k. And therefore, this timing equals to 72, and it will equal to 12.5 h. So k equals to 12.5 h, which is what we want to show. For question 2b, now you're supposed to find the time taken to fill the container, given that your rate is now kt. So rate is another word for a change, so it's the dv dt. Then equals to kt. So now you know your k is 12.5 h. So it will be 12.5 ht. So your v, you just integrate with respect to t, it will be this. And so c must be 0, so because when your t is 0, v is 0, so c is 0. And so now we know that because the total amount is 900h, when b is 900h, we're supposed to find t. And the h cancel out, you're able to get t equals to 12 seconds. And you must also reject the negative because time is positive. So I hope this is clear. The next part is also the same thing, but now you just need to put kt plus 25. And you just integrate the same way and solve equivalent and solve in the usual sense. Because now they give you the time and volume, so you need to find h. And so you can do so because with your time and volume, this part is no more. This part is also some constant, and it will be just some linear equation in h, and you are able to find h to be 10 over 11. So I hope up to now is still clear, and we'll carry on with question 3. For question 3, it tests your concepts of complex numbers. And for complex numbers, what you remember is there is the Cartesian form and then there is the exponential form. And you must be able to know how to switch between the two well. So first, the question is to find the modulus, which is like the length, and the argument, which means the angle it makes with the positive x-axis, of x3, which is x1 times x2. So x1, we know is 3 minus I square root 3. And it's easier to do it in exponential form because it gives you the modulus and the argument of x1. So x1 is this. So when you convert to exponential form, so the modulus now is square root of the coefficients. So this is 3 and this is square root 3. And then the argument will be tangent inverse this minus square root 3 divided by 3. So it's like, because it's like, you must imagine the z is like that, then this is the y, this is the x. That's why the coefficient, the modulus, the length will be Pythagoras theorem, and then the angle it makes will be tangent inverse opposite over adjacent. And so now you get this, and you know square root 2 is already in exponential form. It will help you to solve for x3, because the modulus of x3 now will be the modulus of x1 times the modulus of x2. And the modulus of x1 is square root 12, and the modulus of x2 is half. So you got this, which equivalently means that the modulus is square root 3. As for the argument, because it is multiplied, the formula is the argument plus the argument. So it's not times. You need to take the first argument plus the second argument. And so the first argument is x1 is minus pi over 6. And the second argument is 2 pi over 5. So the argument for z3 is 7 pi over 30. Moving on, we now want to sketch the Argand diagram showing z1, z2, and z3. So the Argand diagram is just basically like your x, like when you draw a graph is xy, or the Argand diagram, this is the real, this is the imaginary. That's about it. And you're drawing it like you draw vector points. So you just need to draw this, label the length, label the angle. And similarly for the rest. This shouldn't be too hard. If you have any questions, just leave it in the comments. Now for part C, it is understanding how the graph looks like. So what do I mean? We're supposed to find the smallest positive integer for z3n to be purely imaginary. So to be purely imaginary, if you look at the Argand diagram, it means z3n must rotate enough times to reach this point over here. And then it must also rotate enough time as it can also lie back here. So it either is pi over 2 minus pi over 2, 3 pi over 2 minus, so 3 pi over 2 is this, minus 3 pi over 2 is behind. Then you just keep adding pi's. So it can be, it just needs to go here, then you just add pi, add pi, add pi, add pi. So you just keep adding, or you can minus, you can go the other direction. And so to be purely imaginary, we just need the argument to be pi over 2 plus some multiple of pi. And we know that argument this means it's n times 7 pi over 3, and it equals to this. So we know that n must equals to minus 15 plus 30k. And so the smallest positive integer now, well, you sub k is 0, then this is minus 15, so it can't. Sub as 1, it can't. Sub as 2, it works, and now it becomes 15. So Z315, the modulus, is just square root 3 to the power of 15, which is this final answer, 2187 square root 3. And this comes to the end of part 1 for this paper. I hope you understand how to do these 3 questions, as this is halfway of the pure mathematics side for paper 2. I'll see you again in the next video, and if you have any questions, you can leave it down in the comments. Please like, share and subscribe, and I'll catch you again. Bye!